Hi, so in today's video we are going to be talking about factors that affect equilibrium and the Le Chatelier's principle. So this right here on the right hand corner is what the principle is. Another way you could say this is changes to the condition of a system at equilibrium can disturb that equilibrium. The system will respond by attempting to counteract that stress until equilibrium is re-established. So there are three factors that affect an equilibrium change. So one would be concentration, temperature, and pressure. A fourth one could be catalyst, but most of the time that does not affect anything on the equilibrium graphs. So first let's talk about concentration changes. On a graph, if you want to know if a concentration has been changed, look for a spike. As you can see on this graph here, the N2 has gone up suddenly. If it is a sudden increase, or say for example NH3 suddenly was to go down, that means NH3 would be removed. But here, as you can see, it is being added. If the change is an increased concentration for N2, the equilibrium will shift in such a way to reduce the concentration of N2. Therefore, the forward reaction would be favored because the forward reaction uses up N2 and converts it into NH3. So if you add a reactant, the forward reaction would be favored and the reactants would go down and products would usually go up. If you remove a reactant, the reverse reaction would be forward and the opposite would happen. So reactants would go up and products would go down. If you were to add products, the reverse reaction would be favored and the reactants would go up and products would go down. And then if you removed a product, the opposite would happen. So the forward reaction would be favored, reactants go down and products go up. This is a simple way to remember concentration changes, and this is the easiest way you can get full marks on an exam if you state. So if a question asks or shows that a reactant is being added, you could say that it favors the forward reaction. As shown, the reactants have gone down and products have gone up, and further on. Another very important thing in concentrations on these graphs would be Kc or Keq calculations. So Kc is you go products over reactants. So another way you could put this is you do C and D, part of your formula equation. You go A and B, and then you do the little symbol of each letter. So that is the formula for it. And another thing to keep in mind is if Kc is 1, the products and reactants are 50-50, so it is even. If Kc is over 1, so bigger than 1, the products would be favored and it is greater in concentration. If Kc is less than 1, the reactants are greater in concentration. Next, let's talk about temperature changes. So temperature changes and pressure changes can be quite similar. However, pressure changes suddenly go down, whereas temperature changes are gradually increasing and then get more stable. So temperature changes can be exothermic or they can be endothermic. This is a key note that you need to know because if you get these the wrong way around, you can lose a significant amount of marks and even get a question fully wrong. So if your reaction is exothermic, and this is how you know if the temperature has decreased or increased. So if it is a temperature increase, then your reactions would go up and your products would go down. If it is a temperature decrease, your reactions would go down and your products would go up. However, if it is an endothermic reaction and your temperature goes up, your reactants would go down and your products would go up. And if the temperature went down, your reactants would go up and your pressure would go down. So this is another tip to remember, which will help you throughout the exam. It will show these on the exam, and it would state whether it is an exothermic or endothermic reaction, and you just have to figure out if it is a temperature increase or temperature decrease. Another thing to note would be that exothermic reactions, they release heat, whereas endothermic reactions, they absorb heat. This is another key thing you can talk about if it is a question. So in an exothermic reaction, if a temperature decrease, the system will produce heat by shifting towards the exothermic side, which is the forward reaction, because that is what the reaction is called. So that would be the forward. And then if it is a reverse, it would be called endothermic, because that is the opposite of what we're doing here. And the same would apply for this. Next, let's talk about volume. Pressure can be also volume. You have to keep that in mind, as you can get asked about volume, but it could mean the same thing as pressure. So if the pressure is decreasing, it will shift towards the side with fewer moles, so less moles. However, if pressure is increasing, it will shift towards the side with more moles. So a trick can be, if it increases, it goes towards the side with more, because it's becoming more and it shifts towards the side with more. And if the pressure is decreasing, it goes towards the side that has decreased or less number of moles. However, another thing to keep in mind is that volume will only imply if there is a gas present in your equation or equilibrium. And for example, for this one, your equation would be this. And as you can see, it obviously will not state that. However, this has 1 mole. So 1 plus 3 would be 4 moles in total. And then this one only has 2. So this one is greater and then this one is lower. So if the pressure increases, the equilibrium will shift to the right because it has less moles. However, if the opposite happens, it will shift towards the left because it has more moles. If that makes sense.